Okay, so you got your scientific method, you've got your problem, you've got your hypothesis that you've come up with, you've created an experiment to test that hypothesis, and now it's time to collect some data. How? Using measuring devices. Measuring devices are marked to a certain place, and you always estimate one place beyond where that measuring device is marked. For example, here we have a beam balance. Mass right now, this says 7, that's the ones place. And this is 0.6, 0.7, it's 7.6 something. And then you'll notice that between 0.6 and 0.7, it's divided into 10 equal parts, each one being 1/100th of a gram. 0.60, 0.61, 0.62, 0.63, 0.64, etc., etc. Now it looks like it's between 0.60 and 0.61, so 0.60 something. Then you have one more digit you can put in. You estimate how far between those two lines your measurement is. Right now, our mass rider is right there. It's a little bit closer, well actually it's a lot closer to 0.60 than it is to 0.61. 0.605? Probably not, it's not halfway between the two. But you might be able to say 0.602 or 7.603. This last digit is an estimated digit, and because you're making a guess on that digit, you can't go any further. I mean, you can't guess and say, well, it's 7.602938427638, because there's absolutely nothing to base that on. Once you get to the point where you're estimating a digit, that's it. Your measurement is done with that estimation. You might look at this and say, well, what about 7.601? Would that be okay? Yeah, absolutely. There is a tight area in which you can do this. So, for example, if you said 7.607, that wouldn't work because this is not 7/10ths of the way across to the next line. So this would not be legitimate. Once you have your measurement written, you have to make sure to put a unit after it to indicate exactly what the number is supposed to represent. In this case, grams, mass, how much something weighs. Something else you're going to be commonly called on to use in the laboratory is a thermometer. This is a Celsius thermometer right here. You'll notice this is 20 and that's 30. It's between 20 and 30, so it's 20 something. Okay. This is 21, 22, 23, 24, 25, 26, 27, 28. It's between 27 and 28, so it's 27 point something. Now, we have no further markings, which means we can only take one more digit. It's going to be an estimated digit. This is about halfway between 27 and 28. 27.5 would be appropriate. Some of you might look at this and say, well, it's just slightly more than halfway. 27.6. Either one of them would be perfectly okay. How about 27.1? Nah. 27.1 would be closer to the 27 line, so we wouldn't want to use that. And again, make sure to remember to put the unit, degrees Celsius, after your measurement. Got to make sure that you have units after all measurements. The final measuring device we're going to look at here is a centimeter ruler. Often it's not going to say centimeter. A lot of times it's going to say metric down below. But if the numbered intervals are about ½ inch apart, you're dealing with centimeters. All right, so we got 14 centimeters and 15 centimeters. So it's 14 point something centimeters. Now if that's 14 and that's 15, then that's 14.1, 2, 3, 4, 5, 6, 7, 8, blah, 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 blah. All right? This is 14.5, that's 14.6. Now, depending on how you look at this, you may say, hey, wait a minute. This is just a little bit before the 14.6 line. Let's call it 14.59 centimeters. Other people might look at this and say, but wait a minute, no, it looks like it's right on that line. 14.6, but you can't stop there, you see, because this measuring device can be read to the nearest hundredth, which means you always have to round it to the nearest hundredth. 14.60 centimeters. Now let's say that line was directly on the 14. You'd have to call it 14.00 centimeters. So if your measuring device can be measured to a certain place, you always have to measure it to that place. And that means putting in some zeros until you get to that place. And that is how you use measuring devices properly. Here's where the idea of precision really comes in. I want you to notice here we have two measuring devices. This one starts at 0, it goes to 1. This one also starts at 0 and also goes to 1. But notice the difference. This doesn't have any markings between the 0 and the 1. This has 10 markings between the 0 and the 1. What does that mean? This is 10 times more precise. So whatever we're going to record this to, we can record this one place smaller. Let me show you. This is 0 and that's 1. This is a little less than halfway between them, so we could call it maybe 0.3 or maybe 0.4 centimeters in length. All right? We can't go any further than that. Our entire measurement is just a guess because there's no guide numbers in here to go by. But put in those extra divisions and oh, it's between 0.3 and 0.4. So it's 0.3 something. We can estimate one more place. It's about halfway between, maybe 0.35 or maybe 0.34, because maybe a smidge closer to 0.3 than 0.4. Either one of those would be legitimate. The important point is you can't go any further because that last digit is an estimation. Therefore, your measurement is done. So to sum up, the fewer markings you have, the less precise your measurement's going to be. The more divisions you have, the more precise your measurement's going to be. Of course, there reaches a point where the divisions are so small that they're kind of useless to the naked eye. So choose your measuring device accordingly.